Hello everyone, this is Athreya and this is a small introduction to me. Welcome to our channel CodeChef. Today we're going to be solving the problem 2 versus 10, which was present in the April lunchtime 2018. The difficulty level of this problem is cakewalk and there are no prerequisites as such in order to solve the problem. So without any further ado, let's get started with the problem statement as usual. Here in the problem statement, it is given that Chef 2 and Chef 10 are playing a game with a number x. In one turn, they can multiply x by 2. The goal of this game is to ultimately make x divisible by 10. So in other words, we need to count the number of repeated multiplications by 2 that we need to perform on a given number x such that at the end of these iterations, our number x is divisible by 10. We need to find the smallest number of turns possible to win the game, or if it's possible to win the game in 0 turns, or if it's impossible. So one question to you at this point is, when will the game end in 0 turns? So pause for a moment and think about this. Exactly. So if our given number x is already divisible by 10, for example, if we have the number x is 100, and 100 is already divisible by 10, this will take 0 turns, because the given number is already divisible by x. Hence, for this problem, we need to find out the smallest number of turns necessary, where in each turn, we can multiply the number x by 2. So we can keep multiplying the number x by 2, changing it, and then, for example, if the number is x, we can make it 2x, and then we can make it 4x, and so on and so forth, until finally, we need to determine that the final number x what we have is divisible by 10 or it is impossible. The constraints here are given below and x can go up to 10 to the power of 9. So in this case, it is better to think of an efficient approach than jumping right into the brute force approach. So as is customary, let's start with a few sample cases that are given. We have 3 test cases here, and the first test case are given x is 10. 10 is already divisible by 10, right? 10 is already divisible by 10, hence this answer is 0. It took 0 turns here to win the game. The second case is 25. X is 25 here. So if we multiply by 2 once, 25 into 2 becomes 50. This is one turn where we have multiplied the number x by 2. 50 now is divisible by 10. Because 50 is divisible by 10, it takes us one turn here. It takes us one turn. Let's look at the next case. They have given x equal to 1. Now I am trying to multiply this x by 2 as many number of times as I can until the final number I am left with is divisible by 10, or I conclude that there is no other way. So how do I do this? First I multiply the x what I have by 2, and now my new x is 2. Then what I do, I multiply this new 2 again by 2. Now I get 4. Now I repeatedly multiply my 4 by 2. Why am I not getting anything that divisible by 10? Then what I have 8. I am multiplying 8 by 2 again. I get 16. Then again I am multiplying 16 by 2 and I get 32. So if you closely notice the units place here, I started here in the second iteration, first iteration I got 2, and now again in the units place I get 2. So now when I again multiply 32 by 2, I will get 64, and this pattern will continue. First I had 2 in the units place, then I had 4 in the units place, then I have 8 in the units place, then I have 6 in the units place, then I have 2 in the units place. Now again I have 4 in the units place, again I will get 8 in the units place, and this is a cycle basically. This is a cycle, and now there is no way you come out of this cycle. Because if you multiply by 2, you get 4. If you multiply by 4, you get 8. If you multiply by 8, you get 16. If you multiply by 2, you get 32. If you multiply by 2, you get 64. And again. So the main thing to note is the units place in this case follows the pattern 2, 4, 8, 6. And again it repeats 2, 4, 8, 6. Again it repeats 2, 4, 8, 6 forever. So there is no way that we get a number divisible by 10 by repeatedly multiplying the given number 1 by 2 as many number of times as we can. So let us, now that you have this understanding, let us look at what approach we can use. The first thing I have written here is, for a number to be divisible by 10, the units place of that number has to be 0. I hope this is clear. For example, 50, 60, 100, 1200. What do all these have in common? All of these numbers are divisible by 10. Because in the units place we have a 0. Any multiple of 10, any multiple will have a 0 in its units place. Because, for example, I multiply 10 with, say, 20, I get 200. Anything, I can multiply 10 with 11, I get 110. So always, because of this property of 10, I'll always have a 0 in the units place. This is what we need to understand. Now what we have seen is, in the units digit, if we already have 0 here, if 0 is already present in the units digit, it is already divisible by 10. So in this case, there are no steps necessary and the answer is 0. In the second case, what we saw in the sample given, suppose the units digit was 1. We did 1 into 2 equal to 2. Then we have 2 into 2 equal to 4. 4 into 2 equal to 8. 8 into 2 is 16 and 16 into 2 is 32. We came back to the digit where we started with. If the units digit is 2, it is this cycle. So you see in none of these numbers, 2, 4, 8, 6, 2, none of these numbers are 0. Unless we get 0 in the units digit, we cannot obtain a number which is divisible by 10. Hence, if the units digit is 1, we don't have any solution. So let us look at the next case. Suppose I have 3 in my units digit. If I have 3 in my units digit, suppose number like 13 or a number like 213 or any number, but 3 is the units digit, what property that follows? So in this case, 3 into 2 is 6. 6 into 2 is 12, 12 into 2 is 24, 24 into 2 is 48, 48 into 2 is 96, 96 into 2 is again, you get 2 back. Now this also is a cycle where we do not see that any of these units places have 0. Hence, even when we have 3 in the units digit, we do not have a solution where our resultant x will be divisible by 10, no matter how many ever times we divide our input number, we multiply our input number by 2. We can multiply our input number by 2 as many number of times as we want, but we will not end up with a number divisible by 10. Let us look at the next case, 5. If we have the units digit ending with 5, for example 15, 25, 155, 2165, in this case, if we just multiply by 2 once, we get 10, which means that 0 will be in our units place. If we get a number x whose units place is already 5, the only thing we need to do is multiply that number by 2 once. So one step is all that's necessary to make such a number divisible by 10. Now pause here for a second and try to write the same approach for digits from 0 to 9, because there are only these 10 possibilities that the units digit can take. We already have written it for 0, 1, 3 and 5. Try to think at least for the other digits for which one of those digits you'll have a solution, for which one of those digits you won't have a solution. Pause for a second and try this. Now let us continue on our approach. The main idea or logic here is numbers divisible by 10 again have to have 0 as their units digit. The second idea that we need to note is if we need to make a number divisible by 10 by repeated multiplications by 2, at some point we will reach this crossroad where something into 2 has to be 10, which means that when we suppose we have a number at the starting and we multiplied that number by 2 and we got a. Now with this new number a, which is basically twice our previous number, with this new number a we again multiply a by 2, we get b. So on and so forth, we do it multiple times and finally we need to get a place where something into 2 will make our units digit 0. Something into 2 has to make our units digit 0 for the resultant number x to be divisible by 10. So think, this is the main crux of the problem. What digit will you place here so that the resultant number will be divisible by 10? We know that we need to get units digit as 0 by multiplying some units digit here, whatever the blank space, into 2. You have possibilities from 0 to 9 for this digit. 0 into 2 is 0, but if the units digit is already 0, it means that the number is already divisible by 10, hence 0 steps are required, and so here we have possibilities from 1 to 9. Try to think what units digit has to take here, the empty blank that I have here, what should be our units digit such that when I multiply the units digit by 2, we get 0 in the units digit. So let's think now. 1 into 2, I get 1 in the units digit. 2 into 2, I get 4 in the units digit. That's not what I want. 3 into 2, I get 6 in the units digit. 7 into 2, I get 14. So think about this for a second. Exactly, we need to put 5 here. Only 5 satisfies this property, that when we have a number already ending with 5, that is if the units digit is 5 for a number already, all we have to do is multiply that number by 2 and we get a new number which is divisible by 10 and who has the units digit as 0. So we need to think about something else now. When can we reach this stage? This is the final stage what we have here, where 5 into 2, the unit digit is already 5 for some number. After repeatedly we multiply something into 2 and we get 10. So is it possible to reach the units digit 5 by repeated multiplications of 2? So I'm just asking you to think that we know this is our ending stage. If we get 5 into 2, we know that that's our ending stage, and if we perform this step, everything is hunky-dory. But how do we reach this stage? Or is it even possible to reach the units digit 5? Is it possible to reach units digit 5 by repeatedly multiplying by 2, by repeatedly multiplying any number by 2? So think about this. If we repeatedly multiply any number by 2 again and again and again, is it possible to land up with the units digit 5? This would mean that we did something into 2, something into 2, something into 2, and we have the units digit of 5 at the end of this operation, which in turn means that we have a set of numbers that we can multiply to get 5. But 5 now is actually a prime number. This number 5 actually has only 2 factors. It has the factor 1 and it has the factor itself. In order to get to this number 5, basically you need to multiply, you need to think whether it's possible to get to this prime number 5 by repeatedly multiplying by 2. If you multiply something by 2, you get something, you multiply that by something, you get something else, and finally, is it possible to land up with 5? No, it is not possible to land up with 5 by repeatedly multiplying by 2. So, one case now, to solve this problem, we are now close to the finish of this problem. The first case is, our number what we have is already divisible. This number is already divisible by 10. The second case what we have is, the number is not divisible by 10 currently, but our units digit is 5. This means that the answer is 1. Here the answer is 0, the number is already divisible by 10. In the second case, the answer is 1 because we have the units digit as 5 and we'll do 1 into 2 step. The third case, no matter what our units digit is, as long as it is not 0 and as long as it is not 5, it can be anything. It can be 1, it can be 2, it can be 3, it can be 4, it can be 6, it can be anything. As long as our unit digit is not 0 or not 5, it can be anything else. We do not have a solution. So hope this part is clear. This was the main approach of the problem. Let's look at the code of the approach that we just discussed. I've taken the number of test cases t as input, and right now we're looking to take the number x as input. I've taken x also as input. Just think back to the 3 cases that we discussed about. The first case was when the number x was already divisible by 10. So how do we check this? We check if when we divide the number x with 10, we get no remainder. If we get no remainder, it means that the number x is divisible by 10. So here we can directly write that this number is divisible by 10. So the number of steps are 0. There are 0 steps required to convert this number into divisible by 10 by multiple repetitions of multiplications by 2. So if a number is divisible by 10, 0 steps. The number is already divisible by 10 while you multiply it by 2 again. Else, if our last digit is equal to 5. So how do we check if a number's last digit equal to 5? This is done by taking the modulus operator with 10. I suggest you take a few examples for this. If we take the example of number 43, if we do 43 mod 10, what is the remainder after dividing the number 43 with 10? 43 by 10 we do, and the remainder actually is 3. How? 10 fours are 40. 43 minus 40 equal to 3. Always, due to the property that 10 has 0 as its units digit and all its multiples have the same property, whenever we divide a number by 10 and take the modulus operator, we will get the last digit of that number. Hence, now we are checking if that last digit is 5. If our last digit is 5, it takes one step. What we'll do, if we have a number like 56, 55, if we have a number like 55, we will take the number 55, we'll multiply by 2 once, and then we get a number like 110, and then that number is divisible by 10. Similarly, if we take the example of a number 65 or 505, in all these cases where the units digit is 5, we just take that number, do one step. In that one step, we will multiply that number by 2, and then our job is over. So that is the second case. Otherwise, if the unit digit is not 0 or not 5, in any of the other cases, it is not even possible through repeated multiplications of 2 to make the number divisible by 10. So we output minus 1. So it is always necessary when we code any problem to check whether the time complexity is sufficient to pass all the test cases. In this case, we see that we have only simple operations like modulus, and that we have very simple operations, and we don't even have loops in this case.
And if you're interested in competitive programming and want to learn and master data structures and algorithms, then this is the one-stop solution for you. Every week we post CodeChef problem explanations, frequently asked interview problems, conceptual videos on various programming topics, and even live problem-solving sessions. Here's a gentle reminder to hit that subscribe button if you haven't already done so.